Hello and welcome to a new video of Tech Talks. In this, we are going to talk about structural and coding bugs in software testing. Let's start with a bug. What is a bug? A bug is a most unwelcome word in the software development process. A bug indicates a fault, error, or failure in the software or a system being built that produces unexpected results. A bug identified needs to be tracked and fixed to ensure optimum quality in the software or system being developed. The journey of an error in the code to being recognized as a bug is explained below. Bug and its source. A bug is actually an error which would have been introduced in due course of the software development lifecycle. The most common sources of bugs are detailed below. Ambiguous requirements. Unclear requirement is a source of bugs being introduced. This can be avoided by having strong static testing techniques, reviews, walkthroughs, etc. Next, programming errors. Incorrect coding standards in a source which can be minimized with proper code review and unit testing. Unachievable deadlines. Stringent timelines often lead to bugs which can be avoided if proper planning is done to ensure timelines are driven based on the estimates. Every bug not only breaks the functionality it occurs in but also has a probabilities of causing a ripple effect in which other areas of the application. This ripple effect needs to be evaluated when fixing any bug. Lack of foresight in anticipating such issues can cause serious problems and increase in bug count. Bugs in software testing and its impact. The impact of the bug is measured based on the severity and the priority. Impact to business is measured in terms of severity, whereas impact to business execution is measured in terms of priority. The table below is a standard definition used across the software industries for severities. Critical. A critical defect would create a major disruption to the business operations. A severe application problem causing considerable downtime, financial penalty, or loss of integrity with customers. High. A major defect would result in loss of business functionality and would require a workaround in production. Medium. A defect which would have a medium impact on business functions but could be immediately managed or work around. Low. A cosmetic only defect which would have no business or user impact. Priority determines the impact of business execution and subsequently how quickly the defect needs to be fixed to ensure the project plan is on track. The table below is a standard definition used across the software industries for the priorities. Immediate. Any problem that is stopping all uses of the software by the business, that is, nothing else can be executed until this problem has been solved or corrected. High. A major function or feature has been disabled or is incorrect, causing a severe degradation in the service. Medium. An issue which signifies one of the multiple streams of testing other than the critical path. Low. Business can still proceed with a workaround and the fix can be applied in isolation. Now let's talk about the life cycle of a bug life cycle. Every reported bug follows a life cycle till closure. A bug life cycle illustrates the journey of a bug from time it is created to the time it is fixed and closed. A generic bug life cycle is explained below. You can refer to the diagram. The description for each status in the life cycle mentioned above are in the table. New. When a defect is posted, the default status is new. Open. When the defect is accepted by the developers, it is moved to the open status. Rejected. When the defect is rejected by the developers, it is moved to the rejected status. Fixed. When the defect is fixed by the developers, it is moved to the fixed status. Reopen. If the testing has failed, the defect is moved to reopen status. Closed. If the testing has passed, the defect is moved to the closed status. Now let's talk about coding bugs. Coding errors of all kinds can create any of the other kind of bugs. Syntax errors are generally not important in scheme of things if the source language translator has adequate syntax checking. If a program has many syntax errors, then we should expect many logic and coding bugs. The documentation bugs are also considered as coding bugs, which may mislead the maintenance programmers. That's it for coding bugs. Structural bugs. Various categories in structural bug include control and sequence bugs. Control and sequence bugs include paths left out, unreachable code, improper nesting of loops, loop back or loop termination criteria, incorrect, missing process steps, duplicated processing, unnecessary processing, ramping, go-tos, ill-conceived, not properly planned, switches, spaghetti code, and worst of all, Pehinko code. One reason for control flow bugs is that this area is amenable, supportive to the theoretical treatment. Most of the control flow bugs are easily tested and caught in unit testing. Another reason for control flow bugs is that use of old code, especially ALP and COBOL code, are dominated by control flow bugs. Control and sequence bugs at all levels are caught by testing, especially structural testing, more specifically path testing combined with a bottom line function test based on the specification. Logic bugs. Bugs in logic, especially those related to misunderstanding how case statements and logic operators behave, singly and combinations. Also include evaluations of Boolean expressions in deeply nested if then else constructs. If the bugs are part of logic, that is Boolean processing not related to control flow, they are characterized as processing bugs. If the bugs are part of logical expressions, that is control flow statement, which is used to direct the control flow, then they are categorized as control flow bugs. Next is processing bugs. Processing bugs include arithmetic bugs, algebraic mathematical functions, evaluations, algorithmic selection, and general processing. Examples of processing bugs include incorrect conversions from one data representation to other, ignoring overflow, improper use of greater than or equal to, etc. Although these bugs are frequent, they tend to be caught in good unit testing. Initialization bugs. Initialization bugs are common. Initialization bugs can be improper and superfluous. Superfluous bugs are generally less harmful but can affect performance. Typical initialization bugs include forgetting to initialize the variable before first use, assuming that they are initialized elsewhere, initializing to the wrong format, representation or type, etc. Explicit declaration of the variables as in Pascal, can reduce some initialization problems. Last in structural bugs are data flow bugs and anomalies. Most initialization bugs are special case of data flow anomalies. A data flow anomaly occurs where there is a path along which we expect to do something unreasonable with data, such as using an uninitialized variable, attempting to use a variable before it exists, modifying and then not storing or using the result, or initializing twice without an intermediate use. Bugs in software testing and cost to fix. There is no set cost one can ascribe to the software bug. However, the cost of a bug goes up based on how far down the software development lifecycle bug is found. Any bug found in production, the code needs to go back to the beginning of the SDLC, that stands for Software Development Lifecycle, where the development cycle can restart. The figure below illustrates the cost fixing a bug depending on the SDLC phase it is identified. Now you can see here, if the bug is found in the initial stage, the cost is less, and as the process goes on, the graph increases, that is the cost of the bug fixing. Methods for finding bugs. Research and self-study. This mainly entails gaining in-depth knowledge of the feature being implemented. As a test representative, the most common remark that is made by the development team is in most forums is that the testers do not have a complete understanding of the feature, due to which they find it challenging to determine what is a program defect and what is not. As a tester, even if you are not directly involved in technical HLD review meetings, it is very important to reach out to the concerned developers and request them to provide a copy of HLD, use case documents or any similar technical input documentation, which will serve as a good knowledge base to understand the feature deeply. Another excellent practice is to have meetings with the developers and discuss the technical aspects to the feature being implemented. Communication and more of it serves as invaluable medium to gain in-depth knowledge, a good foothold on not only the product or the software that you are a part of, but also consumers and pros products. Planning test scenarios. Needless to mention, the research and knowledge part of it's inevitable in any phase of the testing and bug finding. After the preliminary stage of self-education, a good amount of thought must be invested in planning and test scenarios. It is an obvious fact, test case planning is a very important phase in the testing life cycle. The test cases you design and the plan are a direct report of the quality of the product and the extent of testing performed. The test cases outlined have an exponentially proportional relationship to the stability of the software that will go out to the customers. After having read a use case document or any technical functional input document, spend a lot of thought in designing the test case. There must be a good distribution of happy path scenarios and error path scenarios. Also record some effort on the alternative path scenarios and create ad hoc out of the box scenarios. Investigating setup readiness. At most of the times in the testing cycle, the test team has some amount of time on hands before the actual testing commences. When there are time like this, It's a good practice to evaluate the infrastructure that will be used for the testing. Testers find themselves in situations where many of their defects will be setup related and are rejected as there is no fix that can be delivered from the code point of view. Testers often find it frustrating in the testing cycle to find most of the defects getting rejected due to setup issues, even if the test goal is hindered in actuality. Neither there is any test progress nor there are valid defects to indicate why there is a hindrance. Some other times it so happens that a particular test gives a particular erroneous result the first time but gives a different result in every other run. This makes the defect replication extremely challenging. Most developers do not have the patience and inclination to figure out something going on the wrong side of the feature they implement. Make sure to reach out to the required help to stabilize the infrastructure as early as possible. Testing techniques to find defects. Getting to the most interesting part of our job, testing, in turn finding defects. We are those fortunate people who make developers improvise their code quality to a large extent. Discovering the weakness. While you test, it's very important to have the bent of mind to drill down to the deepest level and make an attempt bring out the point where the code might break. Happy path testing. The first thing to do would be to keep an eye on the number of days allotted to complete the testing for a piece of code. In those days, keep aside a reasonable portion of time for happy path testing and happy path scenarios and start with them first. It is like that you may not find many bugs here because all developers make sure the unit tests the happy path effectively. Error path. Next, move on the error path scenarios. Make sure you spend a good chunk of time for testing the error path scenarios. This kind of testing is often the most fun part. You can get as creative as you like. You are most likely to find issues here. Ad hoc or creative testing. Although very commonly this segment of testing can be classified under the error path, it's good to dedicate some last few days of this activity. I have found several valid defects with the ad hoc and negative testing. Communication with the developers before filing a defect. Although, as a tester, we are not entitled to touch base with the developers and can open defects in case we find an issue. I make a strong recommendation to all my juniors to definitely communicate to the issue observed. That's it for the video. Thank you for watching.